Hello everyone, thank you for joining this video. In this video we are going to see a code pattern where we will be able to provision a complete infrastructure on GCP or for Linux machine using Pulumi, an infrastructure as code tool. And we will be able also to deploy a Kubernetes cluster on this for Linux machine using Pyinfra, which is a tool like Ansible, but instead of having the playbook written in YAML, it has them written on pure Python, which offers more flexibility. Then we're gonna expose this cluster to the outside world and deploy some Python application on it, one Python application. So the schema target is the following. The cluster will be composed of 3 Linux machines with one control plane, one master machine, and 2 workers. The user will be able to interact with the cluster for administration through kubectl, or the user can reach the application of the cluster through HTTP calls that will be forwarded from the load balancer to the node workers, and from the node workers they will be forwarded to an Nginx ingress controller service to the apps. That said, let's see a little bit our code layout, how it looks like. So we have here just file. It's a command runner just like makefile, but it's a little bit more flexible and offers some nice features like you can list your command and more other features. So if the most important part here in our project layouts are the following. We have an infra part. This part contains the description of the infrastructure. It's this code described tells to Pulumi, I want you to provision 4 instances and then output their IPs here. We have the Python application part. It's a Flask-like server, but I'm using Sonic, a more modern framework than Flask. We have also the Kubernetes manifest parts. So it's the description of the manifests that will describe our app deployed in Kubernetes. And finally, we have the deploy part. It contains the deploys used by Pyinfra. The deploys are the equivalent of playbook in Ansible. So for us, the main deploy will be the one that set up Kubernetes at first. But before doing this, let's provision our Linux machines. So I will run a command. So this command, basically what it does, so this command will run Pulumi against this main file, and this main file that contains the description of provision of our Linux machine. And then when the infrastructure will be provisioned, we will see that we will have new machines here, and we will see the outputs of their IPs. And why we need the outputs of their IPs? Because if we come back to Pyinfra needs an inventory and then a deploy or a set of operation or a playbook if you want. The inventory contains the IPs of the machine grouped in groups. So we'll see how it looks like. So this is the former IPs I had when I was testing. So I will maybe have the same one, maybe other ones, maybe the same one in another order. For example, here, this is the IP, the new IP of the control plane. It was previously for the load balancer. Here, the new IP of the load balancer. So Pyinfra will recognize this as groups in the deploys. So I had this one, I had this, no, this is a new one. Okay. You might ask me a question, how Pulumi recognize my project. I have already some environment variable. You will see them in the README that are filled with information about my project. Also, my project is already initialized with gcloud init. Okay, so now what we will do, we will SSH to the control plane and show that it doesn't contain any kubectl. Okay, so when I will run kubectl, it doesn't work. Now what I will do, I will install Kubernetes on the nodes. And exactly what's gonna happen, this is the deploy that's gonna be run against the workers on the control plane. So here I'm installing some dependencies. I'm installing Docker. I'm installing these are the most important binary, the kubelets and kubeadmin in all the nodes. Just set up this. Okay. And then specifically in the control plane, I'm installing kubectl. I will initialize the cluster with kubeadmin. And these are the most important, and generate a token that I will use later. The details of the other operation are contained in my Medium article that I will point on later in the video. So now what is happening is the Docker installation. Pyinfra, I can include tasks. It takes some time, a little time, but we're gonna use this time to explain other things. So I can include tasks. For example, I have task of Docker installation. So Pyinfra allows you to include tasks. Okay, so now we're in the step of installing the kubelet kubeadm. Okay, once we will the cluster will be initialized, we won't have directly the workers associated to the cluster. So the next step will be to join the worker to the cluster, and we will see that it won't be associated directly to the cluster. It's almost finished. Okay, so it's finished. So now we will SSH to the control plane. Just check again the IP of the control plane. This is the IP of the control plane. Okay, so now I will have the cluster, but the cluster doesn't contain the other workers. To have the other workers, I have another command, join workers. But let's see what happens in the what command is run in Pyinfra with Pyinfra. Join. Okay, so I'm running this deploy. Basically, this deploy is just gonna read a file here that has been generated by the previous command and run this command on the workers, and they will join. So now when I will SSH to the control plane, I rerun the same command from previously. I should be able to see the other nodes. There, here I have my Kubernetes cluster. Congrats. So now what I would like to do, I would like to do two things. I would like to configure the load balancer, and I would like also to install the Nginx controller, ingress controller. So I think we will start with the ingress controller, Nginx ingress controller. Just to say, there are many implementation of this Nginx ingress controller. There are two famous one known. I am using one. I will try to have it again. Yes, I'm using this one. Nginx ingress controller. Okay, and I'm using one file provided by this one. I'm just the file should be here, or metal, yes, the file is here, but I do a slight modification of this file. I'm taking this file, but I do a slight modification. So this file, I have it here, but what I do, the slight modification that I'm doing is I'm templating it to be sure to have control over the value assigned to the node port. Otherwise, they will be completely random. So I will deploy this. I will deploy the ingress controller. I will just see the command ingress deploy Nginx controller. This is the command. So now I have the ingress controller. So I can check. I can go directly to the master node or control plane and check. But I don't know in which namespace it is, so I will check in all namespaces. So it's in the namespace ingress Nginx. So this is the deploy of the ingress Nginx controller. So the ingress Nginx controller acts like a proxy. It's like a deployment that is able to read the configuration in the ingress objects of Kubernetes and apply this configuration. So the last step will be last step of configuration management will be to configure this load balancer, which I will do. And this step is running this deployment. And this deployment, what it does, it will take an Nginx configuration and it will use the worker IPs to configure this this server, as it plays the role of load balancer. So it's gonna use this template, fill this part with the worker IPs seen in the inventory here. As when we reach this load balancer, we can reach these worker nodes. So just to see again what it does. Okay, so we install the Nginx on the server, and we copy the file, but we render it as a Jinja file, given the context of the IPs of the worker. It's a list of the IPs of the workers, and then we ensure that the service is running. Okay, so it's worked. So now what I will do, I can do two things. I will do something before I can SSH and do kubectl create a service and try to reach it. Or what I will do, I will deploy one of the services I have here, but kubectl won't work directly. What I'm doing here, won't work directly from my local machine. Why? Because the network used in GCP is not the internet network, and the kube config that I will have the IP not of my machine or of the network interface, but it has the IP of the internal network of GCP. So if I want to use this kube config, I should change this IP by the IP of the IP of the control plane. But even if it won't be enough, because the kubeconfig has been the kubeadmin initialization took the previous IP. So to be able to use this IP, I have to regenerate the certificate using kubeadm. I'm explaining this well in my article and giving some reference for more detail, but here I have just a small script that do the job for me. Here, what I have done, I have exported the .env to this environment to run directly the command. Something is missing. The inventory, yes. Okay, so once this step completed, I should be able to connect. Doesn't work yet. Maybe we'll yes, it doesn't work yet because the kube API server should be killed, as it can take the new configuration. So I should kill this pod. Oh, it has been killed by the script. So it's just a question of time. I'll check again. Oh, it works. It just had to wait some time. Okay, so now that I have kubectl working, I can directly deploy from my local machine. And what I will deploy, first I will deploy a simple Nginx. We will test it. That returns a hello world. It's just a configuration of hello world, and then I will deploy the application we've seen earlier. Okay, so I've deployed this. I will get pods. So it is creating the container, and I should be able to reach this this service once it deployed. So in the ingress, not this one but this one, I should be able to reach the service with this route. So here I will give the IP of the load balancer. I think I'm listening on port 80, and then something is wrong. Say previous. Yes, sorry, the node ports. I forgot. I'm reaching on the node ports. 3080. It's the node ports. Okay, that we have seen earlier in the Jinja file. Not this one, this one. Okay. So I'm reaching, but I just change the IP up. We'll use this IP instead. Still something is not correct, so I don't know what is it. So previous command. Doesn't work. What I will do, I will check again. So it's running, should be exposed. I will check. So this is normal, we're doing some troubleshooting, so it's normal. I'll check it's working here. I'll check the ingress. I'm using an extension Kubernetes for VS Code. It should be working here. So why it doesn't work? So I'm reaching this on the ports. It actually should be the port 80, because the port should be 80 here, and then the ports here are 3080, but here should be 80. Not yet. No, doesn't work. What if I do just this? I'll check here if the load balancer is doing well. I don't have many options. What happens if I curl locally? Okay, if I say hello world, I'll check the Kubernetes configuration. The Nginx configuration. Yeah, should be fine. When I receive here, I'm saying to when I receive something on the port 80, forward it please to this server or this server. Now what I will do, I will try directly to reach these servers. Directly this server from without going to the load balancer and see the result. Doesn't work. I think it's a problem with curl maybe. Maybe I should be okay. It was the problem with character. I'm sorry. Okay, so we can I think I will let this in this video. As you can see, also the troubleshooting, it might be helpful. So now what I will do, I will go to the load balancer. So to the IP to the load balancer, not to the IP of the worker directly, because I went through the IP of the worker directly. Yes, and the load balancers listen on 80 and not on 380. So it works great. So our deployment here works of Nginx. Now I'm gonna use the deployment of my Python application, which is already built, and you can find it in Docker Hub through this name. So I will do the deployment. So now I have my Sanic app that is getting created. So it is loaded from Docker Hub. For information, if you don't have a GCP project, you can just create an account and claim $300 of free credits that will be available for 1 month. So you can use it as playground and for your testing, etc. Okay, so now it's running. So I will do the same command from earlier, but you will see that the ingress here is not the same. I will ask for Sanic app. So this is my message from Sanic. So that's it, I think. Thank you for watching this video. I hope you liked it. Thanks.